So just quickly, remember, if something likes to lose electrons, electrodes, remember something likes to lose electrons, there's going to be a lot of electrons, negative charge would build up on it. Negative potential indicates that whatever the substance it likes to lose electrons. Vice versa, if something likes to gain electrons, then the electrode, the metallic electrode, which is in this case platinum, would be electron deficient, because all the electrons would be gained by that substance and it will be electron deficient. It will have a positive charge. So positive potential or higher potential indicates that it likes to gain electrons. And potentials, I explained to you that potentials, every measurement is a relative term. There's everything is measured against something, against a standard. So potentials, the value itself is meaningless. Whether someone is 5 feet and 11 inches tall, or whether he's 183 centimeters tall, the centimeter and the foot are just relative to, I mean, they're just units of measurements. You compare it with something, right? So the point is that 1.36 volts, and it has no meaning unless you compare it with something. For example, so we want to figure out whether it's a higher potential compared to something or lower potential compared to something. And I told you that all these potentials were calculated using a reference electrode, which is the standard hydrogen electrode. You pick an electrode and you measure these potentials with respect to that particular electrode, which is the standard hydrogen electrode. So these potentials, 0.77 indicate karta hai ki it's higher compared to the standard hydrogen electrode. It has a higher tendency to gain electrons compared to the standard hydrogen electrode. Vice versa, if you get a negative potential, that indicates that it has a lower potential compared to the standard hydrogen electrode. So ये basic idea था कि higher E naught, ठीक है? So remember, it's not positive or negative. It's not the value. It's relative value. It's whether it's higher or whether it's lower. ठीक है? That would indicate whether it likes to gain electrons or whether it likes to lose electrons. You have to do that in comparison to something. So yesterday we did standard hydrogen electrode, and I told you that whenever you want to measure the potential, this standard hydrogen electrode always it has to be there. It's got to be there. It's hydrogen gas in equilibrium with hydrogen ions. This is the reference that's given you a zero potential. Because it literally has zero potential, because if you want to measure the reference electrode potential with respect to the reference electrode potential, you're going to get 0 volts. So the reference will always have zero potential, and if you do the iron electrode next to it, it will have a higher potential, which will have a potential difference of 0.77. So the voltmeter over here will give you 0.77 volts. So this is how up here we did the whole 3 types of electrodes thing. Okay. So yes, are clear? Is this all clear? Is that all clear? And yes or no, is this clear? And I'll just show you a couple of questions. Kahan pe? Achha, so one second. Especially the older ones. The older ones had a lot more diagrams in them, electrochemistry, just like in 2014. I mean, they come in newer ones as well, but not the recent ones, 2020, 2021. You didn't have a lot of drawing questions. But normally you used to get big questions on just the drawing part. So, for example, this one. Although this is not, they're connecting 2 different electrodes together, we just have to label them. So there's an electrode that has, so they're saying that 2 electrodes are connected together. A copper 2 copper electrode, which is basically this one. Copper 2 plus ions in equilibrium with copper. You can have a look at the data booklet. Copper 2 and copper electrode. This is another way of writing the electrodes. You just write that the equilibrium is between copper 2 ions and copper. You can just open the data booklet and go to the go to these equations and you will see copper 2 in equilibrium with copper. So here's your copper 2, which is in equilibrium with copper. So they're talking about this specific electrode, which has a voltage of 0.34 volts. Because this one has a voltage of 0.34 volts. And मुझे कोई explain how would you label this? What is this made out of? When you have a metal in equilibrium with metal ions, what is the electrode made up of? What is A? When a metal is involved, what do you make the electrode out of? Do you make it out of platinum or do you make it out of copper? Okay, anyone? Lisha, Anna, Shan? Nee, not platinum. Let me just revise. Let me just quickly revise. 3 types of electrodes. Remember this. When you have first type, when you have a metal in equilibrium with aqueous ions, the electrode is itself made out of the metal. In that case, because you don't need another electrode, you don't need another conducting material because the metal itself is capable of acting as the electrode. Okay. And so when you have a gas in equilibrium with aqueous ions, now you have an issue. Okay, अगर Cl2 आएगा तो कहाँ से करेगा gain electrons? Where would it gain those electrons? So now you need a platinum electrode. You need an inert electrode because the Cl2 and the Cl ions, they can't act as a metal electrode. So now you need to insert a metal electrode, which is going to be platinum, right? And the gas would be in a gas jar, and the ions would be in the solution. And then you have जब दोनों ही aqueous ions होंगे. So that's also when you need a platinum electrode. Like if Fe3 plus wants to gain electrons, where would it gain those electrons from? So you would need to insert an electrode which would be made out of platinum because it's inert. Okay. So remember 3 types of electrodes. Let's continue. This is going to be made out of copper, and the solution will have copper 2 plus. And since there's a not over here, a standard word used kara, so that means the concentration of copper 2 plus ions would be 1 mole per dm cube. You can make sure you mention the conditions. On the other hand, you have an Fe2 and Fe electrode. That's again, iski value dekh lete hain. It's Fe2 plus in equilibrium with Fe. So there's going to be plus 2 electrons in equilibrium with Fe. So again, it's going to be made out of Fe, right? The electrode is going to be made out of Fe, and the solution will have Fe2 plus ions. And the concentration, remember square brackets is a notation for concentration. It's going to be 1 mole per decimeter cube. Beach में you would need a voltmeter. Okay, and there's one thing missing. What is that one thing that's missing? One last thing that's missing. Anyone? Okay, that's your bridge. Okay, salt bridge. I didn't explain why the salt bridge is needed, but for now, just for drawing sake, remember you need a salt bridge. Okay. Otherwise, the circuit will not be complete. But I'll explain this in detail. Okay, once I said, remember this is called a cell now. Okay, this is an electrode. This is an electrode. But if you connect 2 electrodes together, that's an electrochemical cell. So let's say A to D, so you're going to get these questions, and you'll be asked to. You'll get similar questions. Just 5-6 marks of questions, or you'll get just showing those other questions. Again, they're asking you to label this. Now, this is clearly a hydrogen electrode, so C would be hydrogen ions, and B would be made out of platinum. Remember this: when you have a gas, there's no metal involved. The electrode is then made from platinum. It's made out of platinum. This would be platinum. These are going to be your hydrogen ions, aqueous. 1 mole per dm cube. You mentioned 1 mole per dm cube. On the other side, you've got a lead electrode. So this would be made out of lead itself. So that's A would be a voltmeter, and you have a salt bridge. एक और देख लेते हैं. As again, you've got so that's clearly your hydrogen electrode because it's got hydrogen and hydrochloric acid. That's H+1 ions in the solution. So bas ek second quickly. ये फिर से they're asking you to label this. So I think that's your hydrogen electrode. So they're trying to measure the potential of Ag+1. This would be made out of silver, and it's in equilibrium with silver ions. लेकिन चलो ठीक है, बाकी बाद में करेंगे. I just wanted to show you questions about drawings. ठीक है, remember drawings are important, 4-5 marks. अच्छा, यहाँ तक clear. Now I'm going to try and talk about the functioning of the electrochemical cell. We're going to move towards. अच्छा, clear है सारों को यहाँ तक? And keep that in mind. Higher potential gains electrons, lower potential loses electrons. So now moving towards electrochemical cell, although we did already move towards electrochemical cell. So first, अब इसको formally कर लेते हैं. We're talking about the electrochemical cell now. And keep that in mind. Higher potential gains electrons, lower potential likes to lose electrons, relatively speaking. So the electrochemical cell is when you connect two half electrodes together, When two electrodes are connected, what happens is when two electrodes are connected, what happens is that electrons would flow towards positive potential, towards higher potential. Electrons flow towards, from lower to higher potential. To higher E naught. Keep this in mind always, that electrons would always flow, as electrons would always flow towards the higher potential. Higher का मतलब positive होता है, ठीक है? Lower means, the notation usually is that the lower one is the negative one, but it's not according to the measurement. It's not literally the negative one. It's the lower one, and the positive notation is the one that's higher. Like if I have one electrode at 0.2 volts and the other one at 0.8 volts, the 0.8 would be considered the positive potential and the 0.2 would be considered your negative potential. So electrons flow from lower to higher potential. And I'm going to connect two electrodes together. But before that, let's do an equation. We know already that if I react sodium with, let's say copper 2 plus, right? I know that sodium is more reactive, so it's going to displace copper ions. Okay, we know from O-levels reactivity Cs, this is what's going to happen. That sodium ions will be formed and copper will get reduced. And there's going to be two sodiums. So we already know this. This is what's going to happen, that that sodium, being the more reactive one, will lose electrons, two of them, and will form +1 ions. And copper ions, which are the unreactive ones, they would end up gaining those electrons and it will turn into copper. Okay? So we already know this reaction. What I'm going to do now is I'm going to try and figure this equation using the half electrodes. So there's a sodium ion electrode. So I've got a piece of sodium, and that's in equilibrium with sodium ions. Okay, so I've got a solution that contains sodium ions. And I've got on the other side, I've got copper in equilibrium with copper ions. Okay, remember, I already know the equation. I'm just trying to predict the equation using by constructing an electrochemical cell. I've got this other one, which is going to be copper. So this is going to be my copper electrode, and there's going to be copper ions in the solution. Okay, let's say you've got copper ions in the solution. Achha, from the data booklet, I'll be able to figure out the potentials of both electrodes. If you open the data booklet, so copper is samne, copper 2 plus in equilibrium with not copper ions. I want copper ions to be in equilibrium with copper. Achha, the potential is 0.34. So, and where's sodium? Sodium is this one, the first one over here. Sodium ions in equilibrium with sodium, that's minus 2.71. Both these values are given. So I'm going to write these values. This electrode is minus 2.71 volts. While this one, the other one over here, that's 0.34 volts, right? And equations we need to like that. Okay. This is what's happening over here. Na plus 1 in equilibrium with Na. And you got copper 2 plus in equilibrium with copper. So I've written both equilibriums that are going on. Sodium is losing electrons, sodium ions are forming electrons, gaining electrons to form sodium back again. So one thing you'll notice over here is the notation that remember, these are every electrode in equilibrium sets up. Okay, we did talk about it. In the forward direction, the standard notation is that in the forward direction, they gain electrons. In the backward direction, they lose electrons. Remember, we don't know in which direction the equilibrium will go. Okay, it only, on its own, it's an equilibrium. Whether sodium ions want to gain electrons or whether sodium wants to lose electrons, that will be determined by the potential over here. TK will talk about that later. But at the moment, the notation is that forward mein it's going to gain and backward mein it's going to lose electrons. TK, so that's the standard notation that's used everywhere. Iodine gaining electrons to form I-1, I-1 losing electrons to form I2. Potassium ions gaining electrons to form potassium, or vice versa, potassium losing electrons to form potassium ions. So the equilibrium reaction is written. Okay, now based on the potential, we're going to figure out whether it's going to go forward or whether it's going to go backward. Okay, because remember, higher potential and lower potential, that's a relative term. So remember how the notation is written. It's forward is gain of electrons, backward is loss of electrons. But coming back to this, I'm going to complete the cell first. So what I'm going to do is I'm going to connect both electrodes together. And I'll also put a voltmeter in between. So I've put a voltmeter in between. And I need a salt bridge. Here, that's so let's put a salt bridge there. Don't know why, but let's put it there. Anyways, first thing, in which direction will the electrons flow? Because now there's a potential difference. So left to right, right to left. Minus 2.71 potential, 0.34 potential. Okay, so it's going to be Na2CO. So remember, higher potential, electrons would always get attracted to the more positive potential. So electrons will flow and they're going to flow towards the more. So that's the movement of electrons. Okay, so electrons are flowing from the lower potential to the higher potential. Okay, and a lot of questions would, I mean, there'll always be a 1-mark question where they'll ask you this: in which direction will the electrons flow? And that's easy. Lower se higher ki taraf. Okay. Now remember, once you connect two electrodes together, then there will be no equilibrium because now a reaction has started. Once electrons, they start flowing, a reaction has started, right? What is that reaction? The lower potential is the one that produces electrons. That means कि जो equilibrium है, वो हमने क्या rule पढ़ा था? The lower potential is the one that likes to lose electrons, right? Now it's losing electrons. So that means the lower potential one, it's going in the backward direction. Now we've got a reaction at our hands. Okay, so the equilibrium over here has shifted backwards. It has started producing electrons. Or its reason be, you can also link it with the Lee-Shatler principle that if the electrons start moving to the other side, so the quantity of electrons over here will decrease, right? If the quantity of electrons over here decreases, the equilibrium automatically shifts to the left and starts producing more electrons. So if the electrons continue to leave and go to the other side, which they will, because that's the higher potential, that's where the electrons would go, the quantity of electrons over here will decrease and the equilibrium would start shifting backwards. Yeah, uska simple rule ye hai. Just remember the rule, lower potential likes to lose electrons, that's it. So now the electrode is no longer at equilibrium. A reaction has started and the lower potential one has started to produce electrons. It has started to lose electrons. Okay? Is this part clear? Ye clear sabko? Nisha, Anna, Asib, Shan, Abia, Omar, is this clear? So the idea is, remember the difference between an electrode, a standalone electrode, and a cell. जब वो सोडियम का इलेक्ट्रोड अकेला था ना, कहाँ पे गया? There was ठीक है, it was at equilibrium. It had to reach equilibrium because the electrons were not going anywhere, right? So when it was all alone, it had to be at equilibrium because it's not going to produce electrons endlessly. At a point, the electrons would be so much, I mean, there would be so many electrons that the electrons would start attracting the sodium ions back again and it would reach an equilibrium. But it's not going to be at equilibrium if it is connected with another electrode. So in that case, depending on the relative value, if it is the lower potential, then it is the one that's going to produce electrons. It's going to go in the backward. So what will happen over here? We can connect this with the whole equilibrium thing as well, Lee-Shatler principle. What's happening here? Higher potential gains electrons. So all the electrons are getting attracted to it. So if the electrons are coming from the other side, that means the amount of electrons over here increase. If the amount of electrons over here increase, then that means the equilibrium would shift in the forward direction. And the rule is that the higher potential gains electrons. So you can either link it with the Lee-Shatler principle, or you can just remember the rule, which is that the higher E0 gains electrons. That's it. So now you know what each of the electrodes would do. Lower E0 loses electrons, higher E0 gains electrons. So instead of them being at equilibrium, they're no longer at equilibrium. This is losing and this is gaining. That's it. And you can write the overall reaction that is happening. Yahan pe kya ho raha hai? Sodium is turning into sodium ions. So I'm going to write this equation. So sodium turning into sodium ions. So I'm writing the reverse reaction. This is what's happening. Sodium turning into sodium ions, right? What's happening over here? Copper 2 plus turning into copper. So copper 2 plus, they're gaining 2 electrons and they are turning into, so they are turning into copper. And you can simply add the two reactions together. If you add this reaction, you have to make the electrons gain and loss equal. So it's going to be 2, and this would be 2. The electrons gain and loss, they have to be made equal. And the left side should be added. So it's going to be 2 sodiums plus this Cu2 plus. And in my product side, I'm going to have 2Na plus 1 and Cu. So I've figured out the reaction that's going to take place. Okay, so I've able to predict what the redox reaction is, which we already knew. वो पहली equation हम लिख चुके थे. But now, based on this, I have actually been able to predict what the reaction is doing, using electrode potentials. I mean, I didn't even need the diagram. All I need needed to know was I needed to know the electrode potentials, that the lower E naught loses electrons. So I figured out this one loses electrons, and this is the high E naught. So that gains electrons. So this is the one that's going to gain electrons. Write down the two half equations, this losing electrons, that gaining electrons. Add them up, you'll get the reaction. Okay? Ye clear? Is this part clear? Achha, and ठीक है, see, Shan, achha. And one more thing is that not only are we able to predict the reaction, achha, remember, make sure you, so these are your half equations. Okay, so the next step I did over here was add the two half equations. And you make sure that the number of electrons gained and lost are equal. So, and lost, they should be equal. Which is the number of electrons gained and lost, they have to be equal. And now what I'm going to discuss is one more thing. There's going to be a thing called E naught cell. Okay? Every cell has an E naught cell. And that's basically the potential. So that one is basically the potential difference. How do you calculate potential difference in physics? It's higher E naught. So how do you calculate potential difference over here? That's 0.34 volts minus the other one, which is minus 2.71. What do you get for that? That's going to be what? That's going to be 3.05 volts. So you're getting 3.05 volts. So there's a thing called E naught cell. So यहाँ पे मैं उसकी ना explanation लिख देता हूँ. E naught cell is the potential difference. So E naught cell is like in physics. How do you calculate potential difference? That's high E naught minus lower E naught. It's the potential difference between the two electrodes. A better way of writing or describing E naught cell is reduction E naught minus oxidation E naught. I mean, basically, it's the same thing. Okay, high E naught gains electrons, so that's reduction, and the lower E naught is the one that loses electrons, so that is oxidation. But that is a much. I'll explain to you later. But that's a, instead of this one, that one is a much better way of calculating E naught cell. But kind of the same thing. It's like physics. I just figure out the potential difference. So there's going to be listen to this carefully. There's going to be a potential difference that's going to exist between the two electrodes. In this case, it's 3.05 volts. Ye 0.34 hai, this is minus 2.71. So the difference is 3.05 volts. So what does that tell you? Okay, if the potential difference between the two electrodes is very high, that means a large current would flow. I mean, the electrons would travel very quickly, right? If this is very negative and this is very positive, the electrons would flow very, very fast. That means you're going to have a very vigorous reaction. Okay, so the E naught cell, and vice versa, if the potential difference between the two electrodes is very, very small, ye 0.34 hai or ye 0.32 hota, the potential difference would have been very small. The electrons would flow in that case as well, but they would flow very slowly and it would be a very slow reaction. So the E naught cell gives some very important information about how vigorous the reaction is. Okay, so higher E naught cell indicates a vigorous reaction, a feasible reaction. Yeah, more vigorous. or feasible reaction. And any E naught cell below 0, that indicates the reaction will not happen. Below 0 indicates that the electrons will not flow in the direction that you are trying to make them flow. Spontaneous, that's the same thing. Feasible, spontaneous, vigorous, so the E naught cell is very important, and right now it's reduction E naught minus oxidation E naught. So the point is that you can construct, you can figure out any reaction. Who's going to gain electrons, who's going to lose electrons. And if I just open the data booklet, and if I try to do a reaction between, let's say, this one, F minus one, and Fe, right? Then I know that this is the higher potential, so it's going to gain electrons, right? And the Fe1 is the lower potential, so that minus 0.44, so that is the one that's going to lose electrons, right? So I can directly figure out what kind of redox reaction is going to take place. Okay? Is that point clear? Ye clear, Sara? And I can calculate the E naught cell as well, the difference between the two voltages. That will give you how vigorous the reaction is. Jitna zyada difference hoga, the faster the electrons would flow, the more vigorous the redox reaction. Okay? Is this clear to everyone, this one? Ye clear? So now I'll come to the salt bridge. Remember, salt bridge is the least important thing. We don't care about the salt bridge, but एक छोटी statement लिख देता हूँ that is that salt bridge is necessary to complete the circuit. ठीक है, so but I explain the reason for the presence of the salt bridge. So without a salt bridge, nothing will happen. Is necessary